if you enter all of these trig functions into your calculator, you will get these numbers. Cosine of 60 is 1/2, cosine of 120 is -1/2, and so forth. So if you look at this pattern of numbers, what do you notice? Hopefully you notice that across the rows, the values are all the same, except some are positive and some are negative. And the negative signs are different in different columns. All of the values in column 1 are positive, but in each of the other columns, 2 of the numbers are negative and 1 is positive. So the question is, why is that? And the question, why are the numbers the same in each row, and why are the signs different in different columns? Okay, so let's take a look at why this is. So let's start with drawing cosine of 60. 60 degrees is a quadrant 1 angle. So we're gonna do this 60-degree angle right here. There's a 60-degree angle. And I'm going to go ahead and draw a triangle corresponding to the 60-degree angle. And remember that we have to put the perpendicular line or the 90-degree angle on the x-axis. And this is a 30, 60, 90 triangle. So we can label the sides. The short side opposite the 30-degree angle is 1. The longer side off of the 60-degree opposite the 60-degree angle is square root of 3, and the hypotenuse is 2. So we can see using SOHCAHTOA that cosine of 60 is adjacent over hypotenuse, 1/2. Sine of 60 is opposite over hypotenuse, square root of 3/2. And tangent is opposite over adjacent, square root of 3/1. So that's where these three numbers come from. And they're all positive. So there's our quadrant 1 angle. Now, we see then cosine, when we do 120, that is a quadrant 2 angle. So just to recall, these are our angles 0, 90, 180, and 270. So if we look at quadrant 2, we are doing an angle that is in between 90 and 180. So labeling once again 0, 90, 180, and 270, drawing 120 degrees, I would start at 0, go around past 90, 30 more degrees to 120. Okay, so this is 120 degrees. Now, looking at that angle, how do I find trig values? Because 120 degrees is too big to fit in a right triangle. But can you see some place associated with this angle where I could draw a right triangle? Maybe you notice this. Maybe you notice that I could drop a perpendicular line down from the side of the angle into quadrant 2, like this. And because this is 120 degrees, and if I keep going to the rest of the way to 180, I'm going another 60 degrees, I have another 30, 60, 90 triangle. This angle right here, this 60-degree angle, is known as the reference angle for 120. It is the angle that I'm going to refer to when I make a right triangle, because I can't make a right triangle out of 120, so I have to have another angle that's associated with it. So this is called the reference angle. Now if I label the sides of this triangle, you see, I can say now cosine of 120 is 1/2, except it's -1/2. And sine square root of 3/2, and it's positive, and tangent is negative square root of 3. So where did the negative sign come from? Why are cosine and tangent negative? Well, if you look at the way the triangle is labeled, you'll notice that, as we talked about before, the value on the adjacent side of the triangle is an x value, and on the opposite side it's a y value. And notice that in quadrant 2, the x value is going in the negative direction, but the y value is still positive. So this is actually a -1. So this is important to notice. That is a -1, which is why cosine and tangent are both negative, because both the cosine and the tangent involve the adjacent side. So the adjacent side is negative. in quadrant 2. And this is adjacent over hypotenuse, and this is opposite over adjacent. So both of those involve the adjacent side. Sine only involves opposite and hypotenuse, so it is not a negative number. Now, when we go to quadrant 3, now we see 240 degrees is in quadrant 3. So we're going to go down here, 0, 90, 180, and 270. So quadrant 3 is the 240 degree angle falls in quadrant 3. So I start at 0, I go all the way around to 180, and to get to 240 I have to go another 60 degrees, so maybe about right here. So this is 240 degrees. Now, once again, I need to make a right triangle corresponding with 240. That right triangle has to have its right angle on the x-axis. So I am going to make my right angle on the x-axis here. And this will be now, this little angle right here is going to be the reference angle. So this is the reference angle for 240. This was the reference angle for 120. This angle, once again, is 60 degrees. And I have this kind of in the way here. Let's see if I can fit 60 degrees right in here somehow. 60, there, 60 degrees, because 180 plus 60 gives me 240. So I have another 30, 60, 90 triangle. Now notice in quadrant 3, both the x and the y are going in the negative direction. So this is -1 and negative square root of 3. The hypotenuse is still 2. Now you might think, well, why isn't it also negative? It seems to be pointing down. The hypotenuse is not strictly in either the x or the y direction. As a matter of fact, the hypotenuse is the radius of a circle. And so as we do more with this, you'll see where that radius comes from. But right now, just remember that the hypotenuse, when we're in a standard position, the hypotenuse is never negative. Only the two legs could be negative. So we're always going to deal, so we're just thinking about the hypotenuse just tells me how far out I come from the origin in every direction, and that's like the radius of a circle that's centered at the origin, but it's not ever going to be negative. So when I go back and look at my two places where my two trig values that are negative, notice the opposite and adjacent are both negatives. Opposite and adjacent are negative. So notice here, this is adjacent over hypotenuse, which makes cosine negative. This is opposite over hypotenuse, which makes sine negative. But opposite over adjacent, we have a negative over a negative, which gives me a positive. Okay, so negative divided by negative is positive. Tangent is actually positive in quadrant 3. Now, you probably can figure this one out pretty quickly now, having seen all the other ones. If we go to quadrant 4, and this is the angle 300 now, going all the way, and this would be 360 if we go all the way around. So starting at 0 and going all the way around to 300, we're going 30 degrees past 270. So it'd be about right here, 300. Now, where can I draw a right angle? Well, I can draw a right angle right here, a right triangle, and notice what this angle is. This is my reference angle again. And once again, my reference angle is 60 degrees. So for all four of these angles, 60, 120, 240, and 300, the reference angle is 60 degrees. This would be a positive one because I'm going in the positive x direction, but this is negative square root of 3 because I'm going in the negative y direction. And once again, the hypotenuse just remains a positive 2. So in this case, it's the opposite side that's negative. So in quadrant, oops, I named, this is 2, it's supposed to be 3, quadrant 3. In quadrant 4, the opposite side is negative. So that means Cosine isn't negative because it doesn't have the opposite side involved. It's just adjacent over hypotenuse. This is opposite over hypotenuse and opposite over adjacent. So that makes both sine and tangent negative. So notice in quadrant 1, all three values are positive. This is positive, this is positive, this is positive. In quadrant 2, only sine is positive. In quadrant 3, only tangent is positive. And in quadrant 4, only cosine is positive. The reason the numbers in the rows are all the same is because 60, 120, 240, and 300 all have the same reference angle. So something else to remember is that a reference angle always has one side on the x-axis, the adjacent side. So just always remember that you have to have one side on the x-axis. And that will lead us into the next video.